Hi chemistry students. Today we're going to be talking about the lead-2 iodide lab. For this lab, what we're going to look at is, first of all, what's the reaction, how do we do the limiting reactions problem associated with it, and then take a look at some of the parts of the procedure that might be a little bit confusing. So first of all, the reaction here, the two reactants we're going to be dealing with are lead-2 nitrate, so that's PbNO3 2. Remember, we have to have our chart as bales, that's where I got the NO3 2 from. And we're going to react that with potassium iodide, potassium and iodine. So these are going to react together. This is a double replacement reaction. Remember, in a double replacement reaction, we have A, B, C, and D, and this is going to react to form AD and CB. So, in order to do that, now for a reaction, I'm going to take A, which is lead. Remember, lead has a +2 charge, so when we write iodine with it, iodine is -1, so we need the 2 there. And then our C was potassium, and that's going to get paired up with nitrate. And we only need one of each since there's +1, -1, respectively. So the next thing we need to do is balance our equation with coefficients. And to do that here, we need to put 2 here and 2 here. So this is the reaction that we're going to be dealing with. Within this reaction here, what we're going to do as part of our procedure, the potassium iodide, we're going to dissolve in water. So that means it's going to be in aqueous state. Lead nitrate, we're also going to add to the water there, so that will be aqueous. And then the potassium nitrate that we get out of the end is also aqueous. That means that these things are dissolved in water. They're like a saltwater solution. The lead-2 iodide here, though, that's going to form something called a precipitate. And what precipitate means is that that's actually going to form a solid. So if you mix two liquids together and you get a solid that results, that's what we call a precipitate. In this case, what we're going to be looking for, the precipitate is going to be bright yellow in color. So we're going to mix two kind of clear things together and end up with a bright yellow solid at the end. So that's what we're going to be able to measure in our reaction. So, first of all, I'm going to just write or copy our reaction back down onto this slide here. We had lead-2 nitrate plus potassium iodide forming lead-2 iodide and potassium nitrate. Alright, so there's our reaction, so we can reference that. So what we're going to need to do is set up a limiting reactants problem to find which reactant we're going to run out of first. And in our pre-lab, the question that it asks us is, well, if we have 2 grams of our lead-2 nitrate, and we have 1 gram of the potassium iodide, which one do we run out of first? So in our lab, what we're going to be able to kind of measure at the end is potassium iodide. So that's what we're going to be solving for. We have to do 2 stoichiometry problems, one starting from 2 grams of lead-2 nitrate and 1 stoic problem from 1 gram of potassium iodide. Find out which one produces less of our product. So I'm going to go ahead and set these up kind of quickly. So we have 2 grams of lead-2 nitrate. Use some more massive lead-2 nitrate. Get us to moles. Now we do our stoic step. 1 mole of lead-2 nitrate. There's 1 mole of mass of 461 grams lead-2 iodide. So when we go ahead and solve that, we have enough lead-2 nitrate to form 2.67 grams of lead-2 iodide. Alright, so now if we do another stoic problem, this one from 1 gram of potassium iodide, we're going to do the same steps. This is the molar mass of lead-2 iodide, or not lead-2, but potassium iodide rather. So this here will tell us how much lead-2 iodide we can make from the potassium iodide we start with, and that's 1.38 grams of the potassium iodide. So it looks like we can make less of the, that's lead-2 iodide. We can produce less lead-2 iodide from the potassium iodide reaction here. So this is the amount that we can actually produce from 2 grams of lead-2 nitrate and 1 gram of potassium iodide. We can only produce 1.38 grams because at that point we don't have any more iodine atoms to make more of it. So in our reaction, we're going to label the potassium iodide as the limiting reactant, and we're going to limit the lead-2 nitrate as the excess reactant. So those are our limiting and excess reactants. So now there's another question in your pre-lab which asks how much of your excess reactant is going to be left over. So in order to solve for that, what I'm going to do is I'm going to take this value right here, 1.38 grams of lead-2 iodide, and we're going to do a stoic problem to find out how much of the lead-2 nitrate we used up. So 1.38 grams of the lead-2 iodide. We're going to solve, kind of go backwards and solve for the lead-2 nitrate. So we're going to use our molar mass. We've already calculated all these luckily, so we don't have to calculate more molar masses. So by this calculation, we're going to find out how much of the lead-2 nitrate we used up. And it turns out we used up 1.03 grams of the lead-2 nitrate. So what does that mean? Well, we started off with 2 grams of the lead-2 nitrate. We used up 1.03 grams of it. So that means that we used up, or that we have left over, kind of as our excess reagent, we have 0.97 grams of your lead-2 nitrate left over. So I'm going to say it's unused. So that pretty much covers how we're going to solve our problem here. You're going to be doing, when we actually collect data in the lab, instead of having this 1 gram and 2 grams, those are going to actually be the values that you get out of your measurements in the lab. So you're going to actually measure out how much potassium iodide you start with, how much lead 2 nitrate you start with. You'll calculate a theoretical yield, and then in the lab questions it'll ask you to find a percent yield, which means you're going to have to actually find out how much lead 2 iodide you produce and compare it to your theoretical calculation. The last thing we need to do before you're ready to head off and start working on the lab is to create a data table of information you're going to need to collect. So looking back at our previous calculations, for sure, two things that we're going to need to measure out in a table. So I'm not sure how big this is necessarily going to have to be. One of them is going to have to be lead 2 nitrate. And we're going to measure that out in grams. Okay. Something else that we're going to need to for sure measure out, our other reactant, potassium iodide. We're going to need to weigh that in grams. Now, when we go and do filtering, we're going to be using filter paper and gravity filtration. So we're going to need to know the weight of the filter paper. So you're going to want to make sure that you measure this before you put anything in there. And then the last thing that we're going to need to measure is the filter paper. Plus your solid product. So I'm going to just say that's the potassium, or not potassium, but lead 2 iodide. So this is the data that you're going to have to collect in the lab. The first two you collect right away as you actually go and do the reaction. Measure the filter paper before you actually do the filtering. Then you're going to have to let the filter paper and your solid product dry, probably overnight, maybe in a drying oven. And then you're going to, on the second day or the next day, weigh the filter paper and the lead 2 iodide. So these are going to be the 4 data points that you need to collect in the lab.
Alright, well over here we have the materials besides the chemicals themselves that you're going to need for the lead 2 iodide limiting reagent lab. So a couple things that we're going to need here. You're going to need a flask to filter into. You're going to need a funnel. And so this is going to be used for the filtering. You're actually going to be doing the mixing of the chemicals themselves into a 250 milliliter beaker. So you're going to want to make sure that's nice and clean. And you're going to use a stir rod to mix that with your 2 chemicals. You're going to use a watch glass instead of a weigh boat to measure these chemicals out with. So you're going to put that onto your electronic balance, zero your balance, and then put your chemicals onto here. You need filter paper, and then you're also going to need some kind of scoop for, and these should be with the actual lead 2 nitrate and the potassium iodide. Alright, so here we're going to take a look at some of the chemicals that we're going to use in the lead 2 iodide lab. The first one being lead 2 nitrate. And if we look at the safety information about lead 2 nitrate here, what you're going to see is that lead, anything that contains lead in it, including the lead nitrate here, is going to be moderately toxic to you. Now, you don't want to get it on your fingers, you don't want to get it in your eyes, you don't want to ingest it. Ingesting is the easy one to do. But if you got a little bit of on your fingers and you're wearing your goggles and you rubbed your eyes, this could cause a little bit of some irritation and a problem. So you want to make sure that, first of all, you're wearing your safety goggles all the time. That way you can't rub your eyes. And second of all, if you get any of this on your hands, just make sure that you rinse it off in the sinks, use some soap, wash your hands, and make sure that we get rid of that. Now, just a quick note, our product, potassium iodide, is also a lead-containing compound. All the same things apply to that. So that yellow substance we're going to produce, we're going to want to stay away from that just the same way we're going to want to stay away from the lead 2 nitrate. Our other chemical that we're going to be using is potassium iodide. Now, potassium iodide is not as much of a health risk as the lead 2 nitrate or the lead 2 iodide that we're going to be using are. But a quick note, these are a skin irritant. So what that means is that if you get this on your skin, you leave it on your skin for a long time, that you might become a little bit itchy where you got that on there. This is not a large problem. Just make sure that you flush whatever you get the potassium iodide on you in. If you got it on your hand, you want to flush that really well. And again, let's make sure that we're not ingesting or getting these into our eyes.